Can you break down, before we jump in for the listeners, the difference between those techniques and their strengths and weaknesses, just kind of at a high level?
Yes. And there's a good motivation for each one of those and an opportunity and a niche. So supervised learning is backpropagation, gradient descent. And that's what you do when you have examples of behavior that you want. So you have problem situations and you have these solutions that you want the neural network.
You have the inputs and the known correct outputs.
Exactly. And that might be, for instance, image recognition. Is there a cat in this image, or a car or something? Or it might be answering a question when you know what the answer is. And that's the whole cottage industry, is to come up with such data sets, asking humans to label inputs and give you the right answers. And then we have a really powerful mechanism, gradient descent, that allows you to build a neural network that forms that mapping from inputs to outputs. And a lot of this current AI craze comes from that perspective. It was first deep learning, image recognition, and then an architecture called transformers, where we only predict the next word, but as a side effect, learn knowledge about the world. And it's based on backpropagation, gradient descent, but only in a very limited sense, because you're just predicting the next word in your big string of text.
Right.
So it was a lucky break. We didn't actually know that was going to be possible. But
Absolutely.
But it happened with a huge amount of compute, huge amount of data. That simple gradient descent mechanism actually gave you LLMs. So that's one area. Supervised learning, when you know what you're doing, but also by accident, also when you predict the next word, you might actually, with a very large scale up, get something fantastic.